So we're going to be talking about pollution in this lesson. And the first thing that I want you guys to understand about pollution is that, and any garbage really for that matter, is sometimes we think about when we throw garbage away, after we've thrown it away, then it's kind of out of our minds. And something we need to understand about pollution, like garbage, is that there's really no away in throwing. In other words, when we throw something away, it does go somewhere, and all pollution does go somewhere. And it's our responsibility as humans to know where that pollution is going, and as a society to generate plans on how to take care of it so that we can take care of our planet and make sure that the time that we're living here, that we are making our planet habitable and livable for those that will follow us, including our children and our grandchildren. So the first type of pollution I want to talk to you about is pollution in the air. And the example that I want to go through is CFCs, or in other words, chlorofluorocarbons. And this was a chemical that was used in things like refrigerators and freezers and old aerosol containers as like a propellant for them to sort of perform their function. But what we didn't realize that they were doing was that when we would use them, they would get up into the atmosphere and they would break down the ozone layer. Now, the ozone layer is a really important part of our atmosphere because the ozone layer is what protects us from the UV light that comes from the sun. Now, the UV light is light that, when it hits our skin, if we're exposed to too much of it, is what causes sunburns. Now, the reason that we don't go outside and get third-degree sunburns after being outside for a minute is because most of the UV light is reflected back out into space by the ozone layer, this thin layer. It's only a couple inches thick, actually, of ozone. Now, when the CFCs were getting up into the atmosphere, the CFCs were breaking down this ozone layer and causing there to be thinner portions of the layer up high in the atmosphere, and in some cases near the poles, actually holes in the ozone layer. And this was problematic for the health of organisms and for the health of just our global environment. And so there was a ban on CFCs, that they couldn't be used in things anymore. We are still actually, though, still seeing the effects of CFCs in the atmosphere because chlorofluorocarbons take such a long time to break down that they're still up in the atmosphere, still sort of working on the ozone layer. Now, we've seen some gains in terms of the ozone layer getting thicker over the last recent while, which is good. But we need to continue to make sure that we are not putting these chemicals into the atmosphere. And other things in the atmosphere as well can also affect our environment. And so it's always important to realize, okay, what are the chemicals that we are putting into the atmosphere and what kind of an effect are they going to have in a negative way on our life and how the earth handles it? Surface waters is another area that we need to talk about in terms of pollution because we do put a lot of pollutants into surface waters. And one main place where pollutants get into the water system is just from our homes. Things like our sewage and our dishes, we're washing dishes and washing clothes and detergents and watering our lawns and fertilizing our lawns. We have a lot of these chemicals that end up getting into the surface water. And when they get into the surface water, there's obviously lots of viruses and bacteria that could make us sick. And so we have to think of ways to treat that water. So we've been treating water by chlorinating the water. And recently what we've been doing is we've actually been treating water with ultraviolet light. And they've been finding that this is, which is UV light, light from the, not just light from the sun, but we can actually make UV light as well and use it to treat water and clean it out. They're finding that this is actually a little bit better than chlorinating water because, again, using chemicals, we have to be careful and understand that, okay, if we're using too much of these chemicals, what sort of negative effects can come from that? And what we find with chlorinating water is that if we chlorinate the water too much, then we actually create some cancer-causing agents within the water. And so we have to be careful as we're using these chemicals to make sure that we're not overdoing it and creating other problems for us as we're trying to solve these initial ones. So surface waters, we've got to try and make sure that they're clean because obviously we use that for drinking water and whatnot. Groundwater, though, is another one that sometimes when it's out of sight, it's out of mind. And so if we don't see the groundwater, we really don't think of it as as something that we need to take care of. And the problem with groundwater is once the groundwater is contaminated, it's extremely difficult, in fact, nearly impossible to fix. And so the best way to make sure that groundwater stays clean and pollutant free is that we just don't really contaminate it in the first place. Ways that it gets contaminated is we all contribute to this, and farmers have to some degree, treat their crops with chemicals and fertilizers and also pesticides of some kind to make sure that their crops stay clean. But again, overuse of those chemicals is where we get these contaminants that get into the groundwater, and then these contaminants dissolve in the groundwater, and then those contaminants are taken to other places. We contaminate, therefore, aquifers, and they become not usable as far as using them for drinking water and things like that, or at least a lot harder to use for drinking water if we aren't careful with how we are polluting the groundwater with these types of chemicals. So we have pollutants in the air, on the surface, and also underground. And we just have to, the main theme here is we have to make sure that we're taking care of our planet in those regions so that we can go back and use the resources that are there to a beneficial use for us. Now, when we throw away garbage, sometimes you've seen things wrapped in labels where it says that they're biodegradable, and this is great. Biodegradable substances are really good for the environment because these substances can be broken down by bacteria, fungi, or other organisms. Now, lots of times the things that these companies won't tell you is they won't tell you how long it takes sometimes these chemicals to break down. And so there's a list actually in your textbook, table 3.6, that you can find in topic 6 of unit 3 here, the environmental chemistry unit, where it lists a bunch of different chemicals that are biodegradable, but how long does it take them to biodegrade? And so knowing what the substance is made out of and knowing what or how long it takes for that substance to biodegrade can actually inform your decision making on, okay, if I'm going to buy something that's biodegradable, I want it to biodegrade in weeks, not years or decades. And so something to watch out for as a consumer and as you look at buying things in the future to help maybe reduce the amount of pollution that we're making and putting back into the earth. Now, hazardous wastes are going to occur, and we're going to have to throw stuff away. That's just the nature of life. But one way that we can really help with that is that, especially with our hazardous household wastes, is that we can use the 4 R's to help with just really how much we're throwing away in the first place. Now, these 4 R's are listed right here: reduce, reuse, and recycle, and recover. And they're listed from best strategy to the worst strategy. So the best way to reduce the amount of garbage that we're producing is just use less stuff. Just don't buy as much as maybe you normally would or whatever. And if you can reduce the amount of stuff that you're using, then you're just going to have to throw away less. And that's really the best way to reduce the amount of pollution that we're putting back into the atmosphere or into the environment. The next one is reuse, which is just what we are buying. If you can reuse it multiple times before you throw it away, that's best. And then when we do throw it away, if we can recycle it, that's also great. That does cost money, but it is a better way than just throwing it away. And the last way is we can go out and we can pick up garbage, and that's great, and people do that, and it's a necessary thing that does have to happen. But if we don't have to ever recover stuff because we're really utilizing these other 3 R's right here very, very well, then the amount of recovery we have to do is very minimal. And there's just oftentimes places where you just can't go out and recover stuff. Like little pieces of plastic that end up in the ocean, it's just really virtually impossible to make any sort of gains in how much plastic is going into the ocean versus how much we can pull out. And so it's just a lot better to stop the pollution at its source, which is just don't get it into the ocean in the first place. Now, when garbage does get thrown away, we do have to store it. And so there's 2 types of landfills that you guys need to know about. First kind of landfill is what's called a sanitary landfill. And sanitary landfills are kind of organized like this, where you just have the garbage sort of mixed with dirt, and they place them in these compartments, and then they put just a layer of soil around those compartments so that the garbage is really protected from things like scavengers and other organisms that would want to come in and sort of spread it around and make a mess of things. Now, when we store regular garbage in sanitary landfills, which is where most of our garbage goes, some things that we have to be mindful of is that these landfills will produce a high amount of what's called leachate, which is just a liquid that's formed from the decomposition of the garbage. So as decomposers get in there and start to break down a lot of the organic material, a product that they produce is just this sort of slimy, sort of liquidy substance. And you've seen this sometimes at the bottom of garbage bags as they've been sitting in maybe your garbage bin or whatever, and they start to smell a little bit. This leachate has to be filtered out and sent to treatment plants and centers to make sure that we're not contaminating our groundwater and our drinking water on the surface as well. And another thing that we have to make sure that we're taking care of as well is that when the garbage is decomposing in the soil underneath the soil, because it's capped off from the air, this decomposition occurs in what's called an anaerobic condition, which means that the decomposition occurs in the absence of oxygen. And when these decomposers decompose this garbage in the absence of oxygen, they produce methane and carbon dioxide. Now, producing carbon dioxide's not a huge deal. I mean, it is a greenhouse gas, and so that's not great. And so is methane, but methane's sort of a double whammy in that methane is a greenhouse gas, but it's also explosive. It's a flammable gas. And so if we don't take care of this flammable gas in a controlled way, then we can get buildups of methane gas under the ground. And then if there is a spark or something that happens somewhere, then we can get an explosion that happens at these landfills. And that's just not safe for people at any time when we have these uncontrolled explosions that are happening. So what they do is they will take these leachates and they'll actually filter them out, as well as they'll have places where they can draw out the methane from these landfills and burn them off in controlled ways. In other cases, like up in Edmonton, there's a place, some landfills where they will take the methane out and they will also burn the methane to produce electricity for homes. So it's kind of taking that waste and using it to good use, using that R of reuse or recycle to minimize the amount of pollution that we're putting into the atmosphere. And then we have secure landfills. Now, secure landfills are a special type of landfill where they really take care of the really hazardous and very toxic wastes that we're throwing away. And so they have to cap these and store them in places where it has a clay liner on the bottom. And this ground is very non-porous. The porosity of it is basically zero. And this is important because as this stuff again decomposes, we don't want any of these hazardous or toxic chemicals getting into the groundwater. And as I mentioned before, if it gets into the groundwater, there's really no way to clean that up. And so we just want to prevent it from getting in the groundwater altogether. And so the way that we do that is we produce this, or we lay this clay liner down first, then we lay the hazardous wastes on top of it, and then we cap it with a clay liner as well. This diagram doesn't show this, but we cap it with a clay liner and then with some topsoil on top. And then these wells are important here, and it's because, again, decomposition is occurring in anaerobic conditions, so we have to burn the methane off in controlled ways. So there's little flames sometimes that happen right here in these areas where they're burning the methane off in a controlled way. But also they have these testing wells outside. And it's just to make sure that as they do these tests, that they're not finding that these hazardous wastes are leaking through the layers. And if they do a test where they find that they are testing positively for these hazardous and toxic wastes, that they can then make adjustments to this section, do some repairs so that these chemicals are not leaking further down into the groundwater and contaminating things. So one last term that you guys need to know is this term called bioremediation. Now, sometimes contaminants get in the soil and there's nothing we can do about that. And sometimes accidents happen. And what we can do, though, is sometimes there are organisms, plants, for example, or even microorganisms, lots of different living things that can remove contaminants from the soil. And when living things remove contaminants from the soil, we call that bioremediation. So one example of that is back in the 80s, there was a nuclear reactor in the Ukraine in a city called Chernobyl. And the nuclear reactor exploded, leaked a whole bunch of radioactive material into the soils, and contaminated a lot of soils and waterways, groundwater, lots of contamination that happened. And still to this day, there's nobody that lives in Chernobyl because they can't. The radioactivity is just too high. But in the surrounding areas, what the countries did was they went around and planted sunflowers, because sunflowers can actually take out the radioactive materials out of the soil, and they break it down into harmless chemicals and then just deposit them back into the soil. And so for a long time, you just see sunflowers planted in these areas as a bioremediation technique to help restore the ecosystems back to the way that they were. And so it was kind of a neat way of using living things to remediate a really bad situation. And so that term bioremediation is one that you need to know.